Welcome back to the Chem Lab. This week we're going to do our Suzuki coupling reaction, one of our Nobel Prize reactions that we're going to look at this semester. And so what we're going to do is we're going to try to bring together an aryl bromide with an aryl boronic acid here. And we're going to do a little organometallic chemistry. We're going to have a catalyzed reaction that occurs using a palladium catalyst here. And it's a fairly straightforward procedure, pretty much just a mix and stir type of procedure. Though we're going to have to do some things on the workup end to try to clean things up a little bit. So what we've got is there are several possible unknowns in this week's experiment. I'm just going to run this reaction with A1, though you may have a different one that you'll be analyzing. The procedures, however, are all identical. So they look very similar here, so we can just use this one as an example. So in the vial here, I have aryl boronic acid number 1. And I have weighed this out already into the vial. And so we're going to dissolve this up in about 5 to 10 milliliters of our ethanol. And we're going to do rapid stirring here. Now I've got a small round bottom flask. That's 1, 2, oh, I'm doing more than I need to here. 3. We're going to start with this. We'll do one more. Now we want to be able to stir it. This reaction does require vigorous stirring here. So for this type of a round bottom flask, we have a couple different types of stir bar options. This is what's known as a weather vane stir bar. It's got the magnets in the bottom, and then it's got that triangle shape to kind of help stir things up a little bit. So let's go ahead and get that going here. All right, crank that up. Okay. We want to look at it, and we want to get this nice and dissolved before we add any of our other starting material. Okay, looks like we might have gotten it with just that. Oh, I see a little bit of white powder in there, but we're mostly there. Oh, turn our stir bar up too high. Stir plate. Okay, there we go. There's a nice vortex. Oh, there. Now we're spinning. Okay. Mostly dissolved. Okay, we'll give that just a second more. I don't want to add too much solvent because then that's more I have to clean up later on. Ultimately, we're going to want a solid here. But I have, I'm using 95% ethanol as my solvent. And then I have pre-weighed unknown A into here. This is my aryl boronic acid. And so we're going to add our aryl boronic acid directly into the flask here. Just get a spatula up here. Okay. So, looking at that, yep, we got everything dissolved. Now I pre-weighed the vial and then put this material in here so I would know how much I had. I want to transfer as much as you can this way. Okay, but we want to make sure that we get everything out of here. So we're going to use a little bit of our solvent, and we're going to put that in here. About 2 milliliters more of the 95% ethanol. Okay, switch that around, make sure I've got all of my aryl boronic acid. Transfer that. Okay. Now, if you remember from the mechanism that we have, we need 2 more things to be able to get this mechanism to go, or this reaction to go. We need to add our catalyst, which in this case is a palladium solution. And then we'll also need to add some base, and that's necessary for that to activate the transmetallation step. So let's start with the palladium. This is a standardized solution, so we know exactly how much is in here. And so we're going to add 200 microliters of this. Now I have my pipette set to 100 microliters, so we'll just need to give it a couple of shots of this. 1. Get it? Go. And there's 2. All right, so we got our 200 microliters in there. Not cheap stuff, so be careful with that. Palladium's an expensive metal. Okay. Now we're going to let this go a little bit. We want to let it stir for about 2 minutes. before we add our base to it. So today we're going to be using potassium hydroxide. It's about 1 molar. So we're going to have, this is 1 molar dissolved in water, so we're going to have some water in here. So we're going to have a mixture of organic and aqueous layers. And as you look ahead in the procedure, we're going to actually add some water a little bit later on to help our material crash out of solution and to dissolve out anything that we don't want here. Okay, so let's go here. All right, we've gone about 2 minutes now. So we're now going to add our KOH, and we're going to add about 2 milliliters of this. The actual amount is not that specific. We just want approximately 2 mils, so I'm going to use the volumetric, or the plastic disposable pipettes here. Put in my 2 mils. Okay. Now we want to keep this rapidly stirring, and we're going to go for about 20 minutes now. Whoa, we definitely see a change here. I need to note that down in my notebook here. And I put my pen down. There we go. All right, so on the addition, we got a lot of cloudiness. All right, we'll check back in 20 minutes and see what this looks like. The Suzuki reaction here has been stirring for about 20 minutes, and we still have some cloudiness to it, but and it's probably a little hard to see on the camera, but I've got little black specks throughout the reaction as well, and that's my palladium. So when we do our workup, we're going to have to make sure that we get rid of that. But right now, we're going to add some ice cold deionized water here, and then do a little more stirring. And I want you to think about the transmetallation step and why it is that we would need to add this. All right, so let's see, there's 3 milliliters. Okay. Yeah. Definitely see some cloudiness there. Add a couple more here. 3, 4, 5 milliliters. Okay, so we're going to leave that stirring for another 5 minutes, and then we'll come back and work on the next step. Okay, so we've done our additional 5 minutes of stirring with the deionized water in there. And you'll notice that we have, there's the black spots I was talking about earlier, and quite a bit of a white solid in there, as well as the stir bar. So we're going to vacuum filter this on a Hirsch funnel. Once again, I have the trap set up and my filter flask. So we're going to go ahead and turn this on. It starts to make a lot of noise, sorry about that. And go ahead and get my vacuum going. There we go, it's pulling air through there. So we're going to swirl this around a little bit because I want to transfer my solid onto the filter. You gotta be careful you don't put too much over. Ethanol is fairly low boiling, so there's low enough pressure here that we're getting the reaction boiling. That's part of why we have our trap. You might be able to see it's actually dripping down the trap. It's recondensing there. You may have too much solvent for my size flask. I have to swap this out. Yeah, we have to. It's okay. That's why I have another one here. Okay, so we're going to stop the vacuum for a moment. And we could just empty this out, but I don't have a beaker here, so we're going to swap this over. I actually don't want to get rid of that, just in case my product came through. I'm kind of a paranoid filter person, in that I will wait until the very end before I throw anything away. Okay. Now I'm trying to get as much solid to come over here. I'm going to go ahead and let the filter or the stir bar come over as well. Now the directions say that we want to wash this with some cold deionized water. So I have that. And I'm actually going to use that once again, instead of putting it directly on the filter, I'm going to use it to try to swish this out and make sure that I get all of, or as much of my solid as I can to try to improve my yields. Okay. Looks like some solid came through there. We have to be a little careful with that. Another reason for holding on to it. But what do we have? Okay, so I've got my stir bar. And once again, we're going to come in here. We see a nice spot of solid and the stir bar. Okay. So what we're going to do at this point is we're actually going to let this sit for 10 minutes on the vacuum because it's pulling air through there, and as it does it, it ends up drying it. And we want to get this material as dry as we can. So I'll be back in 10 minutes. All right, we've been running for our 10 minutes now, so we have a nice and dry solid, but this solid has a mixture of several things. It's got the product we want, but it probably has some of the side reaction material from the transmetallation step, and it also has some of the palladium that's still in there, none of which we want, because it means a less pure product. It also makes it harder to characterize on NMR and IR and the like. So what we're going to do is we're going to close our vacuum, and we're going to put on a clean flask here on the bottom, because we're going to add methylene chloride to this. Now our product is an organic product, so it will be soluble in the methylene chloride. So what's going to happen is right now, our product is up here. As soon as I add the methylene chloride, it's going to fall through to the bottom. I just want to check on my amount of methylene chloride. Okay, about 2 to 3 mils. Okay. We don't necessarily even need to have the vacuum running. I'm going to be here just in case I do. Let's pull it through here. Depends on how full the filter is. All right, so there's 1 milliliter. Okay. Yep, looks like we're going to have to pull it through. All right, so let's pull a little vacuum. Okay. Then get another mill. And another mill. I'm going to go ahead and do the 3 mils. Now here, the more solvent I use, the more annoying it is in the next step, because I'm actually going to have to evaporate this solvent off. So I want to be a little careful with that. Okay. All right, so 2 to 3 mils of the methylene chloride going through there. Once again, I'm going to pick you up. Put a little vacuum here. There we go. And in here we can see the black specks. That's our palladium that's left over. But our product is now in here. If everything were ideal, this would be completely dry. There'd be no water. And we would have just our methylene chloride. However, that's not true in this case. Water gets trapped in with the product. The air drying gets rid of most of it, but not all of it. So we're going to need to go do a workup here to try to get rid of the water and then to isolate our final product. So we're almost there. Just a couple more steps.